Well, hello and good morning, everyone. And my name is Kieran Swale. I'm a Tourism Innovation Specialist at Southern Regional College in the Business Support Team. And this morning, you are very welcome indeed to the fifth of our winter webinar series at the Business Support Team, supported by Connected NI. Well, today you're in for a treat in every respects. Something that we haven't done in a while. We have three presenters really. My colleague James Donnelly is at the helm, and he's good at that. He really is. He's the driver. James isn't in charge today. James is our engineering specialist in the business support team. Now, James today is helped by two industry specialists, one who's a full-time lecturer in mechatronics, that's Chris Lawson, and then Mark Gray. Mark's from Universal Robots, and he was telling me the company's going 16 years, and he's been 5 years with the company, and his role is to, I suppose, responsible for, he called it a country manager for UK and Ireland. So I have had a sneak peek at some of the things that are coming up, and honestly, you're in for a real insight. Fantastic insight. So whilst this is entitled Automation to Manufacturing, it's not just about that. This will apply to all industries, and certainly anyone from the food background should find this very, very interesting today. Some practical advice and guidelines then. You are automatically muted on entry. Today's webinar is recorded on YouTube, and I'm ably informed by our production manager, Aisling, that that's going to be going up pretty soon today. As well, in the background here today is Caroline and Sarah, part of the business support team, and even though we can't see them, they have an important contribution to make. Okay, so you're on mute. If you have any questions, please would you submit them in the chat box, and we will endeavour to answer those questions at the end. James then is going to be really leading off, and then handing over to Mark and to Chris. And anything that we can't help you with today, certainly if you can email at Better Business, then we'll be able to try and answer your questions or signpost you on. Now, that is enough from me. And now, James, if you are ready to go, James, yeah. Now I'm going to hand over to James, and thank you very much.
Thank you very much, Kieran, there for the introduction. To let you know, my name is James Donnelly. I'm an Innovation Technology Specialist in Engineering at Southern Regional College. A bit of an insight, I have over 20 years hands-on experience with engineering in the local market. I from various industries, from general engineering right the way through to civil engineering, agricultural and recycling. And over my time, I've worked on many projects. Most projects were to do with automation in some regards, whether you're making a machine to go into a system to improve production, that type of thing. Kieran has introduced Chris and Mark there. So as you can see in the slide, Chris is a lecturer at the college. He used to be in industry as well. Mark, he works for Universal Robots, and both will, whenever it comes to their bit, they will be able to tell you more about themselves. So if I go on to the next slide to get started, just a kind of a brief automation in manufacture is really to use of equipment to automate a system or process. So throughout this webinar, we're going to look at this in the industrial applications, where we're using this technology to perform tasks that can be repetitive, dangerous, or otherwise unsafe for humans. So by doing this, we're going to look at two areas: smart factories and cobots. So a wee bit more introduction of industrial automation. It kind of blends itself to high volume manufacture. It uses cutting edge technologies like robots and machine to manufacture parts. Many of the machines are able to communicate easy to each other, and in some cases make decisions. Simply put, this refers to Industry 4.0. As you see in some of the photographs in the slide there, you've got bottle manufacturing technologies like mobile phones and circuit boards. Again, this slide represents the computer programming of simple tasks to make up a system. for a smart factory. As you start from the left and move to the right, obviously programming is important with using robotic arms. So again, this slide further shows examples of how smart factories is used to manufacture toilet paper and filling of cans. Many companies have smart factories such as Amazon, Whirlpool, Coca-Cola, Glen Dimplex, My Park. And this stage, I'll hand you off to Chris Lawson. Chris, if you want to take it.
Thanks very much, James. That's brilliant. Appreciate the introduction there. So just as James was saying, my name is Chris Lawson. I'm a lecturer here in the college, and I've been lecturing here for the past 6 years, mostly in the areas of mechatronic engineering and automation. And really what we're just going to show you here is there's a video going to play in the background. I'm just going to talk over it, and it's showing you what mechatronics and automation is like in the college. It's giving you a bit of a glimpse into what we do in the college. And this is some of the students' projects. So it's exactly what they've been working on. I appreciate maybe it's a little bit hard to see exactly what's going on. There's a lot of equipment. We actually have a range of equipment in the college here in terms of automation and mechatronics. We've recently spent about £1 million over the past 3 years on this type of equipment. So students, when they're coming into the college, they really do get hands-on experience. Now, 3 kind of key players in automation for us at the college here is robotics, which you can see there by the 2 universal robots that are in action, and Mark is going to give us a great discussion on them in a little bit. And we also have PLC programming and electro-pneumatics. And part of our stations that you can see maybe around the conveyor there is we have small modular production stations, which basically mimic different tasks that happen in industry. So we have the likes of sorting operations, orientation, machining, packaging, assembly. We have a number of these stations that students can use. They can build, they can program, and they can try and integrate into a full sort of production line. And that's really what we have here. We've got students, and they're programming the robots. They're learning how to program the PLC stations. They're building these systems and putting them together, and getting that foundation and practical knowledge in the insights of automation. Now, what can we do for you in terms of industry? Well, we deliver, and myself, I've delivered a lot of industrial courses on these topic areas for different companies. We've most recently done one with Glen Dimplex there at the moment, where we've had them come in and learn a bit more and get a bit of better insight into the universal robots. And I have to say, we've been a big supporter of universal robots here in the college. The students have found them excellent, and Mark will give you a bit of an insight there to how easy they are to set up and integrate into the factory floor. And we've really seen that for ourselves as well. They're extremely flexible solutions, and very easy to use and very productive. So that's just kind of some of the things we can do. We can deliver training courses on some of these areas for companies. We can offer a consultation on some of the projects that you may be working on. We can go through maybe some kind of prototype development of systems and different things that you're looking for. So there's a lot of options here at the college that we really can look into for you. So if you do have any questions about what you can sort of see here at the college, feel free to put them into the chat. If you even all going well, COVID pending down the line, if you want to come in and have a look at some of the equipment and some of the resources that we have in the college, I'll be more than happy to show individuals or companies around. Really, it's maybe hard to show exactly on videos, but when you come into the college, we have quite a large footprint in mechatronics and automation, and that might give you a better insight as well to what we can offer. So that's just, as I said, a bit of an insight. It shows you that as a technical college, we are using the latest and greatest equipment that's out there, and we're here and ready to support you as best we can. Thanks very much.
Thank you very much, Chris. I'm going to go and do a very quick summary of the advantages briefly on the disadvantages of using such robots and stuff. And so the advantages is that you don't need as much skilled people. It reduces employee costs. It's safer because it's taking humans out of it. It increases productivity. The robots can go 24 hours a day, 7 days a week, and quality, because everything is so precise, the quality improves. Some of the disadvantages would be the initial cost, worker displacement and loss of jobs. And another disadvantage, which people forget about, is maintenance. There would be a maintenance, you'd have to keep the robots up to date, keep maintaining them, and if a robot breaks down in a system, the whole system could end up coming to a halt. So it's important to realize that where if one human got sick, you can replace, get somebody in to cover, So I'm going to talk about the cobots with Mark Gray. I'm not going to say too much to let Mark introduce himself here, if that's okay. So if I hand it over to you, Mark.
Thanks, James, and thanks for inviting me here to speak today. So I work for Universal Robots, and we're a Danish company, and we're based in a town called Odense in Denmark, where all the robots are made. And this one small town is only famous for two things. It's the birthplace of Hans Christian Andersen, but there's more than 100 robot companies based in this small town of 100,000 people. So it's the worldwide centre for collaborative robots, and it's a European centre for robotics. And we were set up by 3 university professors specifically for small, medium enterprises, because that's what most of Denmark is made up of. And they wanted to find out why those small companies wouldn't use robotics. And from that research, they found that there were 5 key reasons, and then they set about solving those key reasons, and the cobots were born. Next slide, please, James. So we wanted to make it easy for people to be able to think about having no automation in their factory to get to the first sort of robotics that they could start to import. And robotics is coming. It's a technology that's being more widely used than ever. And we have a huge labour gap in our labour market at the moment that automation is going to be one of the things that's going to help fill that. So we created this thing called the 3IP method, which is a pathway that you can follow the steps to get to automation and then make your business more sustainable. Next slide, please, James. So these are the robots that we manufacture. We've got 4 robots in the side in the range. And on the left-hand side, you can see the UR3 robot, which is a kind of smaller desktop robot, which will carry out tasks like pick and place and assembly and screwdrivering and so on. Then you've got the UR5, which is a little bit bigger. It's about similar dimensions to a human arm. And that might replace a task where somebody sat down at a bench, putting parts in and out of a machine, or assembling, putting clips on, or screwdriving and so on. And then the UR16 has got a heavier duty payload, so that might do packaging at the end of line for putting parts into boxes or putting parts into machines. And then you've got the UR10, which is the largest robot we do. And that might take over tasks where somebody stood at the end of a production line, putting boxes onto a pallet, or welding something, or reaching into a machine. Next slide, please, James. So these were the 5 key reasons that the university professors found that was stopping smaller companies use robots. So they set about making those things that were our value drivers. So we pride ourselves that our robots are very easy to program. Industrial robots are generally very difficult to program, but we've created a programming language called Polyscope, where there are templates and wizards where anybody can program a robot. I could teach anybody to program a simple pick and place task within about 5 minutes. And this software is actually taught in secondary schools in Denmark. Now, what's unusual is we give this software free as a download. So you can download it from the website, put it onto a USB key, and then upgrade your robot as you would like a normal mobile phone or something. We also pride ourselves on a quick setup. We realize that's important for small businesses in the fact that they need to get something into production and running straight away. So all our robots are out of the box ready. They come preloaded with software and pre-calibrated. Plug into a 13-amp socket and you can get them running straight away. And we also found that robots generally are designed in a fixed location. They can't be moved. So because collaborative robots are very lightweight, they can be moved around the factory to carry out different tasks as and when you need them. So they're kind of future-proof. They're not just designed for one thing. They can be moved around and they'll change and move with your business. Now, the definition of a collaborative robot as opposed to an industrial robot is it's a robot that can share the workspace with a human without the machine guarding around. And how we do that is we limit the robots in 3 factors. We're limited by the amount of weight we can carry. So the maximum weight we can carry is 16 kilos. The speed we can travel, the maximum speed we can travel is 1 meter per second. And the force we can exert, the maximum force we can exert is 250 newtons. Now, to be safe, we monitor the robot's joints continually, and we monitor the force in the joints. So if the robot bumps into somebody, we immediately put it into what we call a safeguard stop. We control the stop. And there's also an emergency stop on the robot controller as well. So you've got 2 classifications of stop: a kind of nuisance stop if somebody like elbows it or bumps into it, and a real emergency stop. Now, we also pride ourselves in having a quick payback, because small companies want to buy something and get it paid for really quickly. So a typical payback time, if you're on 1 shift, is between 9 to 12 months. Next slide, please, James. Now, one of the things that James talked about there is there's an increasing concern with employees that robots are going to take everybody's jobs and will all be made redundant. What we found is cobots don't take jobs, they take tasks. And you take the tasks that you don't want the humans to do. And the example you can see on screen there is there's a lady building up motorcycle panniers for a company called Shad. And they've taken some of the task away from her. The robot's got a screwdriver on the end of it, and it's inserting screws into the panniers. So she builds up 2 panniers side by side. After she finishes building the first one, the robot swings in and puts the screws in while she builds up the second, and then it swings around and puts the screws in the second, and then she takes the first one out. You've task balanced that by taking some of the tasks that you don't want her to do, but by doing that, you've actually increased her productivity. Now, the UK suffers from one of the lowest rates of productivity in the G7. We have a massive opportunity to increase our productivity across our entire manufacturing sector. And by taking some of the tasks out of these cells and balancing them with a person, you can make huge gains in productivity. So the real factor is cobots don't take jobs, they take tasks. And by increasing productivity, you make businesses more sustainable. Next slide, please, James. So these are the main application groups that robots have been used for. And I've recorded webinars on each of these topics, which you can stream from our website. So we've done them on also things as diverse as laboratory automation, right through to gluing and screwdriving and so on. And you can stream them from our website free of charge, and you can see application stories where they've been used. Next slide, please, James. So this is the 3IP method that we discussed. This is the automation pathway. Next slide, please, James. So basically, this is a way that we've created all the resources available for you to install a robot and then bring it into your business and make you more resilient. So the first step is identify. There are lots of online library videos and webinars that you can watch that might relate to the manufacturing sector that you're in. And that'll give you an indication of whether it's possible to automate the tasks that you have on your factory floor. So if it's things like welding or machine tending, we've done lots of that, and you can watch similar case studies to what you're facing in your own factory. You can also arrange a free automation audit. Either one of our guys or one of the site distributors can do a free audit and look at the application, and they'll help you specify what you require. The second stage is implement. You can use the resources available to install the robot in the shortest time possible. So that might be a DIY installation where you get trained and you can buy UR Plus components that fit with the robot to give you an off-the-peg solution, and you can install it yourselves. Or we have integrators that can help with that. So there is an option, a choice of either doing it in-house or actually getting an external company to come and help. And then the third stage is the improve. You can actually see what savings you've made and monitor the performance of the robot and the cell and see how your productivity is increased and how you've managed to fill that gap with your labour problem. And the last part is, once you've made those savings, after a year the robot's paid for itself. The second year it's made enough money to buy another robot for another task, because robots ultimately become cost neutral. Once they've paid for themselves, they're then earning money. Next slide, please, James. So we've got some customer stories that we're going to share, case stories of people that are in the same sort of situations that have used robots to help them make the businesses more sustainable. Next slide, please, James. So this is a company called AFK Garden Furniture over in Lincolnshire, and they're a small company of 15 people, and they make all the garden furniture, planters and arbors for all the big supermarkets and all the garden centres. And they had Polish workers working for them that went home before Brexit, so it left them with a real labour gap. So they mounted two robots upside down on these slide kits with Merkur sanders to carry out sanding tasks on this particular part. And they had an increase in orders, so they've been really busy during lockdown. People were spending more money on buying garden furniture, and that meant that they needed to ramp up production. And the shortage of the workers left them the only option to look at robotics, because they were advertising for people 6 months and couldn't find anybody to fill that labour gap. So they implemented these two robots to carry out the sanding task. And the floor space that they had in the factory wasn't a massive factory, so they needed something that would fit into this small corner of the factory. So an industrial robot wouldn't be feasible. Next slide, please, James. So they needed to increase their performance with this shortage of workers that they had. So they got two UR10 robots working together to follow these pre-taught sanding paths, and they can sand any type of panel. So the example you can see in the picture there is an arbor, but they make planters, seats, all sorts of different things, and they can sand any of those particular shapes. Once they've programmed it, it resides in the robot's memory as a menu, and they can recall that the next time they make that shape. The changeover time has been saved because now they can just call up software rather than to change tooling. And they've also seen a reduction in operator fatigue. So instead of having a guy stood there with a sander for 8 hours a day, the guy actually just loads the parts in and loads the parts off while he's doing something else. And they've seen their increase of their overall business increase by 20%. Now, the robots paid for themselves within 12 months, and 12 months later, that financed another pair of robots. So this small company of 15 people now has 7 robots, and they're actually looking at another 2 for this year, for 2022, to carry out tasks like screwdriving and painting. Next slide, please, James. So this is a company called ASD Lighting over in Rotherham, and they make street lights. And they needed to increase their productivity because there was a rising demand in the market for their products. And also, when new products were being developed, they needed flexibility on the production lines to change over really quickly. So the production volumes are increasing year on year for these guys. Most of the street lights are being changed in the UK at the moment for LED street lights to save on energy and reduce lighting pollution. So a typical batch size used to be 500 lights, but that's now increased to sort of 5,000 lights at the moment. And where they are in Rotherham, they found it a real problem to try and find staff, but also hold on to staff for a longer period of time. And when new products were introduced, it was generally a really difficult thing for them to do because they had to change the tooling to suit the parts. By using the robots, again, they're just using software. Next slide, please, James. So they managed to get 3 wins on this. They managed to minimize the amount of errors they made and increase the productivity and take away these tasks from the operators. So the small robots that you saw there sit on the opposite side of the conveyor, and it allowed them to work in the same space constraints they had without having to put safety fencing around them, even though they had screwdrivers on the end. And the UR5 can detect missing screws and issues a warning signal. So they're monitoring the performance with the actual force torque sensor of the robot so that they're not sending bad product to the next station. Now, what they found is their productivity has increased from 300 units a day to 450 units a day. And that marked increase is because the robots set the pace on the production loops. So whereas they had a production loop with 10 people before, the 2 people on the screwdriving stations actually could only go as fast as the rest of the line, and they only produced 300 units. By taking those 2 people out and putting 2 robots in, they've increased that productivity to 450 units. So basically what they've managed to do is to redeploy those other people with feeding the line with empty shells and taking finished products off. So they haven't lost anybody, they've actually just changed their task. Now that's reduced staff occurrence of RSIs and stopped people getting injured as well. Next slide, please, James. So this is a company called eTech. They're a small machining shop based up in Blackburn. And what they do is they make these components for military defence parts, and they wanted to get the robot to run a night shift. And it's a small company with a real diverse customer base. So people can bring them parts that they need making in simple one-offs. And they were having a real difficulty in finding labour to do night shifts and so on. And they needed quick turnarounds for these sort of one-offs, but they also had this increasing volume on this particular part. So you can see the robot's got a dual gripper on the end. It's taking a blank part in, it's taking the finished part out, and then it'll give the HASS machine a signal to start. And then it'll press the button, it has a little finger, and then it'll drop the part onto the tray. Next slide, please, James. So E-Tech actually carried this out themselves, and they saw a return on investment in less than 12 months. Now, they had 3 processes they needed to address. They needed a loading table, which you can see in the front of the picture, that they load the parts on, and a datum fixture, so the robot drops the part onto the datum, so it's always in the same orientation. And they needed a way of moving the robot out of the way of the machine. So you can see it's mounted on rails on the side of the CNC machine. So during the day, somebody can bring in a part that they need working on. They can slide the robot out of the way, carry on with the HASS machine as normal, and then when it gets to home time, 5 o'clock, we slide the robot into position, press start, and then it'll just working on this tray of parts during the evening. And when they come in the morning, they've got those products all finished. Now, they managed to do it themselves, and they programmed it with some training from one of the local distributors. And what it found for them is that they have 40% gain in productivity instantly. Now, they've also got a real simple implementation they used, and that low cost saw them get a return on investment in less than 12 months, and that's actually financed the next robot. So these guys now have 2 robots with them. Next slide, please, James. So this is for a company called PMI. It was a weld shop, and they were facing a real shortage of trained welders, which is endemic in the industry, I think, at the moment. And automation was one of the key factors for them, because many businesses were facing labour shortage of skilled staff. They just couldn't find them. And what it was doing was making them turn away some business, because some of the projects they needed to carry out required 10 welders, but they actually only had 7 guys. And traditional robotic welders weren't really feasible for them because they have a high mix and low volume turnover of parts. So what they did is they created a collaborative robot cell where the robot carries out the welding on real simple sort of tasks. And those simple tasks are things like brackets and really sort of low-tech assemblies. Next slide, please, James. So what they found is when they did that, they used the robot to carry out the real simple stuff, and they let the skilled welders concentrate on the real value tasks, where the human skill is the most valuable asset any business has. And to get the most value out of that, you need to let your skilled guys use their skills to really do the best part of the installation you can. The real simple stuff, the repetitive stuff and the boring stuff is where the robots can really help. Now, they managed to get an integrated software solution, and that put that into this that controlled the welding source. It was a complete welding cell. And that meant that non-certified welders were able to load the program and swap between parts in just 15 minutes. So the robots aren't replacing labour, they're letting the skilled welders do the larger components where they can add value on seams and things like that. The robots take over the really dull stuff. And what they saw is that 50% decrease of labour cost meant that they were more sustainable in the market, and they started to win more business. So by implementing robots, it actually made them a safer business to continue. Next slide, please, James. Okay, I understand we've got some questions that have come up in the chat pane.
Yeah, if I could jump in there, Mark, because I'll hand back to James before we go to the questions. James, will I hand back to you for a second, and then will we take questions, or will we go straight to questions?
That's fine.
Okay. If you want me to read through the questions and answer them as they relate to me, I can do that. So, water egress into the robots, yep. So the IP rating of the robots is IP54, which means that they're not suitable for washdown areas. They tend to be in low care areas of the food industry, which is end of line packing. Somebody asked, what's the typical pick speeds of robots? So that a collaborative speed is 250 millimeters a second. So we talk about a typical pick speed from full extension to full extension of about 2.8 seconds. So it's not a super quick like a spider robot. It's generally slower picks to be collaborative. It can pick quicker if it's surrounded by a garden. Somebody also asked, who's the distributors in Northern Ireland for Universal Robots? So we've got 2 distributors that cover that area. We have one that's based in Dublin, which is Reliance Automation. They cover the whole of the island of Ireland. And we also have RAR, who are based in the UK in just outside London, and they also cover the north as well. Somebody asked about the IP rating. Yeah, and are they suitable for washdown? We've answered that. No, they're IP54. There are suits that you can put on the robot to increase the IP rating, where you can put them in it, but you have to move them in and out of the area so you're not jet washing them and so on. And then somebody's asked, what's the uptake of cobots in the food industry? So the food industry is interesting in the fact that it's a very labor-intensive industry. It tends to be more of either the in-feed of things like bakery lines for recycling, things like trays, baking trays, putting onto conveyors and putting things on paper onto trays and so on. And then at the other end, it tends to be palletizing, case packing, and pick and place. The actual processing of food, we do have them in things like bakeries by spraying water onto the tops of loaves and things like that for like French bread and decorating biscuits. But in the UK, the vast majority tends to be end-of-line packed, low care end. And we have them in things like bakeries, sandwiches factories, things like confectionery and crisps and so on. They tend to be the biggest industry that uses lightweight and relatively high speed through.
Okay.
Any more questions?
There are, if I'll hand back to James after this, but if I could just come in, and there's a couple more, again, just sharing this with the audience, James. How does SRC work with, what companies have they worked with? And Christopher's answered that in terms of Glendimplex that was mentioned, Thompson Aero and Tato. Also, we have 40 local companies between Newry and Portadown here signed up to Mechatronics, the apprenticeship program. We have Mechatronics labs ourselves at SRC in both our Newry and our Portadown campuses. The question from Paul, he's talking about the food industry actually. Concerns in robotics would be water ingress. What advances are there to ensure reliability? And Chris has answered that. Depending on your particular application, some further considerations and adjustments need to be made to the robot to ensure safe operation. And then Mark, you've gone on to talk about that. And another question about where are today's seminars up on our YouTube channel. So just from my end of it, James, that was a fantastic overview, insight you got both from yourself and from Mark, what SRC does and the amount of investment. And then you give us, you give us 4 fantastic examples there. Fascinating, the garden furniture, that was just fascinating for me as a non-engineer to see that. And the thing about the lighting, that's really, really interesting. So James, I think at this stage, I'm going to hand back to you, and then I know if you want to jump in here.
No, listen, I think it's important that we continually work with local businesses. So I suppose if any businesses out there watching, please drop us a line. We'll be looking to do, work with you and probably try to give you an idea of where you can put robots in. And of course, we'll work with Mark there, and he'll obviously help us, I'm sure, So look, if we can get a couple of projects in with local companies, we'll be more than happy to help you. And I suppose that's where we're coming from. There's no point us having equipment if we can't, share it out between local companies and hopefully help people. So that's kind of where I'm coming from with this.
James, there's also a note there from someone about who you'd be familiar with now. It's the Mid Ulster. It's called Mega, the Mid Ulster Network members, and the comment is, if not done so already, can you please engage with the Mega Network members specifically in relation to robotic welding?
Yeah, that's no problem. Look, as it says, like I'm actually very interested in working with local companies and hopefully develop a couple of projects in the next 6 months. So
yeah, I mean, one other question again, Mark, and it struck me was you talked about the poly software and your quote, which is really, I really like it, and obviously it's from a sales distribution. Cobots don't do the jobs, they take the tasks. And then you went on to say, well, sure, anyone could program a robot. And I'm kind of thinking, so if I'm not a coder, could I do that? Do you need a coding background?
You don't need a coding background, no. I mean, it's aimed at people who are non-robot programmers.
Okay.
So one of the things that we see changing is that, as you saw the ladies that were building up the motorcycle panniers there at Shad, they actually program the robots when they change panniers. So you're making the robot as a tool. So a robot in the future will become as ubiquitous as using a screwdriver or a welding torch or something else like that. But you're letting the operator set up the robot. So they actually set the robots up for themselves when they change parts to different types. So it's not difficult at all. It's very, very simple to set up. And that's why the software was developed for that.
And in the, I suppose, modern vehicular world of vehicle transport, e-transport, all of that, where the rises in low carbon footprint and the rise of electronic vehicles, whether they're mopeds or bicycles or electronic cars. I mean, is your company or robots making them a real inroads there?
We are. We do have robots already in Envision in the UK, which is the battery plant for Nissan. And it is actually something that I was speaking to Ford about yesterday. Actually, I had a meeting with a chap who's a European manager for Ford, and Ford are looking at investing in the UK to make electronic powertrains. So the Getrag plant in Speke in Liverpool used to make all the gearboxes for the transit vans, and they're transitioning to make that completely an electric power plant. So eventually they're talking about 600,000 units a year will get shipped out of that plant, and they'll feed into all the European Ford plants for vehicles. So they are looking at cobot technology as all new technologies come into this to make it sort of flexible. And again, to do these kind of tasks that you don't want humans doing anymore, like screwdriver and so on. One of the big things is that we need to improve the kind of workplace for young people coming into the industry. We're passionate about getting young people into the industry. And this is what's fantastic about what James and Chris are doing, is that you're providing a pathway from secondary school kids eventually coming into a college and doing the technical qualification, and then going out into the wider industry and sharing those skills, because those businesses need those skills. The next 5 years are going to be transforming basically our economy, how it's going to work. And all these different, like the example that Chris showed there, like linking up to PLCs, can be things for like making medical devices in the logistics industry, you know, assembly, all these different things. Our economy has the biggest opportunity to transform, because places like Germany already are very, very heavily automated. So they haven't really got many places to go to increase. We have a massive opportunity to transform our economy. It's, you know,
so that learning support, I mean, what's striking me here is, you know, when our students come out and they are employable, and our apprenticeship program is actually is very successful at the moment, and as are our engineering programs, but it's that core skill set that's transferable. And I'm thinking of, so if I was interviewing someone, I'd be asking for what CAD skills do you have and what programs have you done? So when you talked about the Polyscope,
yeah.
Polyscale, yeah. Is there, and do you reach out with other FE universities or colleges on a particular module where somebody could, inverted commas, do this, be qualified in something like Polyscale?
So there is actually a free online portal on our website. We support colleges with, I'm actually carrying out a webinar on education on the 26th of this month.
Great.
Of how we support colleges and universities. And there is a free online web portal that students can go on. They can register with an email address and a password, and they carry out 8 individual modules to learn how to program the robot, very basics to program a robot. And at the end of that, they can print off a certificate. So it's a good grounding for people to get an understanding of the possibilities.
I'll let James and Chris pick up on that, but I think that's brilliant. Absolutely brilliant. That's fantastic. Aisling, are you going to come in and talk a little bit about our support?
Yes, I am, Kieran. Yep.
You want to go ahead there, Aisling?
Yeah.
Are you frozen there, Aisling? Are you okay? Are you ready to go?
Yep, all good. Yeah, can you still hear me okay?
Yeah.
Perfect. The joys of working from home. So, hi everybody. My name's Aisling. I work in the business support team along with Kieran and James. So just like to thank you for that presentation, as well as Chris and Mark. It was really insightful, and I hope everybody got a lot from it this morning. What I'm really here to do is just come on really quickly just to talk about some of the support that we have available here at the college. So I suppose first up, most recently, we've been working on the Skill Up Flexible Skills Fund programme, which is funded by the Department for the Economy. And basically what it is in layman's terms is a range of free courses for anybody. So there's no restrictions, anybody can do the courses, and there's a real wide range, and it's kind of just to upskill the economy as a result of COVID-19. So just to give people a chance to gain new qualifications. So we do have a range of engineering courses within that programme, as well as digital marketing, computing, and various other things. So I'll send a link out at the end of this webinar just so you can all see what's available, and hopefully maybe something will be of interest to you. As well as that, we do have the Skills Focus programme, which is targeted at businesses under 250 employees or social enterprises. So I suppose just in relevance to this webinar, we do have a level 3 robotics course, which will be starting in February, which might be of interest to some businesses, and that will be completely free if you are under 250 employees as well. After this, you'll get the link to apply. We also have the Innovate Us programme, which is also funded by the Department for the Economy, and it's a range of, it's mentoring programme basically for up to 60 hours for companies under 50 employees, and it would be one of the most popular funding streams that the like of James and Kieran would work on. So James could come into your business and give you some mentoring in a particular area. Following on from that, we have innovation vouchers, which are funded by Invest NI, and they're really a way for businesses to tap into the knowledge that we have here in the college. I suppose with this one, it's a little bit different. There is a VAT element to be paid, whereas the other programs are free. Also, as the guys have previously mentioned, we do have higher level apprenticeships in mechatronics as well, which are really popular. And we also have level 2 and level 3 apprenticeships and traineeships in engineering as well, and we're actually seeking some placement opportunities for those guys at the minute. So it would be a level 2 or level 3 student coming into your business for maybe 1 or 2 days a week. So if anybody would be of interest of taking somebody like that on, you know, please let us know after this webinar. We'd be really keen to get talking to you. So I suppose just really encourage anybody who has a need or any type of training need or upskilling or an idea for a new product, service or process, get in touch with us. We're here to help you, and a lot of the programs are funded, so take the opportunity when it's available to you. We're really eager to help you all. If you contact us on betterbusiness@src.se.uk, one of the team will give you a call back. Also, thank you to Connected for funding this morning's webinar. They support us greatly, and we really, really appreciate it. And we think we have 2 more webinars left in the webinar series, so there'll be a link sent out after this, and you can see if there's anything of interest to you as well. And we also will have an evaluation, and we would really appreciate if you would take 2 minutes just to fill it in, just to give us an idea of how you felt the content was this morning. And also there's a wee suggestion box in there if you have any ideas that you would like us to cover, or any webinars you would like us to cover in the future. So
actually, there's a note of one more. It's really support from Reliance Automation. And they've said Reliance Automation would be happy to provide support in realising any potential automation projects, including welding. And the contact is info@relianceautomation.ie. So maybe we'll send that out, Sarah and Caroline and Ashley will send that out as another link with this webinar.
Yeah, that'll be no problem, Kieran.
So, Ashley, do you just want to close out there then? Okay.
Yes, so thank you everybody for joining us this morning. As I say, you'll hopefully receive the email and the link to this morning's webinar on our YouTube channel, so you can send it on to anybody if somebody wasn't able to make it this morning. And also, again, just encourage you to get in contact with us to hopefully avail of some funded support for your business. Thank you all very much. Bye.